Hello everybody. Today I'm going to be talking about MongoDB. I'm going to be giving just like an introduction of it. First we're going to talk about just like what it is, how it compares to relational databases, and then we're going to um, create a situation where you can see like the pluses and negatives of using a relational database like MySQL or using what MongoDB is, which is a document-orientated database. And you can see the positives and negatives for each one of those. And then we're going to get our feet wet and we're going to actually get inside the terminal and like create a database and learn how to manipulate data. Alright, so yeah, MongoDB is what's called a document-orientated database. And that is opposed to the relational database like MySQL that I was talking about. And so like what's the differences? The main difference is that if we look at this, looks like a spreadsheet kind of thing, but this could be representing like a table in a relational database where every record, which would be a row, every record has cells, right? And every cell can only have one value for each field. So like this record's name field can only have Smith as its value, whereas let's say John Smith lived in multiple cities. Like you can only put one value. You can't put two. In MongoDB you can put two. And so yeah, what we're gonna do is we're gonna create a phone book application schema, and we're gonna see different ways that we can structure it. And so the first way that we're gonna structure it is we're gonna have where a person can only have one phone number. That's easy. That doesn't introduce any problems. That doesn't produce any duplication or anything like that. So if we look at this schema, we can see that every contact has a name, a phone number, and a zip code. And so if we just visualize this in like a JavaScripty, JSON-y way, we can see that this would be a record or a row, and these would be the fields, right? Like ID, name, phone number, and then Rick is the value of name. And so that's all easy peasy. That's why are we even doing that? Okay, so but what happens if a person has more than one phone number? Well, one approach that you could do is you could add a second phone number field, which works. If you want to go that way, that works, and it's actually not that bad if people are only gonna ever have two. But the more expandable, the better way, you could say, would be to separate them into two tables where you have a contact table and you have a number table. And the contact table doesn't hold any phone number information. It just holds information about the user like name and zip code, and then the number table holds a reference to the contact that it's associated with, and then it has its phone number. And that way is good, and first way is good too. But not really. The first one's not that good, because you know that's not expandable. If someone has three, you have to continue on and you have to add. And if somebody only has one phone number, then the second one will be nil. Like you can see this example here. Like Morty doesn't have a second phone number, so it's just nil. And you know that's adding more data tables fields than it needs, and so you know that's bad. And then here we can just see the JSON representation of the reference data, where you can see this is a record for the contacts table, and then here we can see a record from the numbers table, which has a reference ID of the contact that it's associated with. And And this way feels the best. Like, you don't feel wrong about using this. This seems like a good way to go about it because it doesn't create any redundancy or anything. But it's bad in ways because it requires a join table whenever you want to like find out what numbers does Morty have. Or, yeah, so what numbers does Morty have? So if we look at this SQL query and we put that as a 2 instead of a 3, that's an error, my mistake. A 2, we can see that we select the name and select the number from contacts and then join it with numbers, so the name comes from contacts and then the number comes from numbers. On contacts, where the ID, the contact's ID equals the number's contact's ID, where contact ID equals 3, so it's going equals 2. So it's going where the name is equal to 2 and then the number's contact ID is equal to 2. So it'll take out these ones and join them together. And joins are bad because they require random seeking, which random seeking may not be that big of a deal anymore if servers have like magnetic disk drives. Like, I'm not sure how they work, but they're bad with magnetic disk drives because it has to seek to that information on the drive, and once it gets there, it can read the data really fast, but it takes like 99% of the total time of querying data is spent on seeking the data, and then less than 1% is actually reading the data. So that is why joins are bad, because they require a lot of random seeking. Right? So now what your options are is you can denormalize, which we're still kind of in the relational database kind of mindset. We haven't talked about MongoDB. But so a normal practice is to denormalize, which just means reintroducing some redundancy in order to make the querying more efficient or just easier to do. And so here we add the name that the phone number is associated to inside the numbers table. So then when you want to make a query of finding the name and the numbers where the name equals Rick, you can see that this is much simpler than this, and it doesn't require a join, so it's much quicker too. So now, MongoDB. So now we're in MongoDB world, right? So MongoDB, you can have more than one value in a cell. So we don't need to split that into two tables of contacts and phone numbers if we don't want to. Like, we can just do this. So we can have, so like this is basically just a contacts table with a field of nums which holds an array of numbers. So if Rick has 2 phone numbers, that's good. That's gravy. If he has 3, just same. If he has 1, it's good. It doesn't matter. Like, it's expandable. That's good. And also, another reason that this is good is because it introduces locality to the information. So when you want to query, like I was saying, once you find the place that you want, all the information is right there. It can read it super quickly. And another thing that's good is when you're deleting information. So like if we see this, like db.contacts.remove id2, id2 is Morty, so it deletes Morty, and it deletes all the numbers that Morty is associated with too, right? Whereas if you do if your schema is set up like this, you delete Morty. And then, you would delete all the numbers where the contact ID is 2, right? But in MongoDB, you can't have like a, you can't do like what in MySQL or relational databases is called like a multi-state transaction, which is where it'll delete the contacts, the contact that you're trying to delete, and then it'll delete all the associated numbers that you're trying to delete too. And if one of them fail, like it does a hard fail, like it doesn't continue on. But with MongoDB, if you have it set up this way, you would delete Morty from it, and then you would delete all the numbers associated with Morty, and it could soft fail, and so like one of them would fail and you wouldn't know it. And another bad thing about that is right after you delete the contact Morty, and you're in the process of deleting the contacts with the ID of 2, systems can query like contact ID 2, and they can get back those phone numbers while the system is deleting them. So like it's a super like small amount of time, but like that is possible. Right, so, but a negative to embedding, which this is called embedding because it's embedding everything like into one table. And a negative to embedding is when you have to make queries, like say you just want numbers with the area code of 651 or whatever, you'll get back this entire record, whereas when you split them into 2 tables, you just get this, which is less data, it's more efficient. So yeah, so now we're going to get into the shell. We're going to look at getting our feet wet and seeing just how do we use MongoDB.